This is Vince Marino Plumbing, LLC in Pittsburgh. Today is March 13th, 2025. I just cleaned and serviced this board. I'm going to do that other one over there. But for the purpose of this video, I'm going to refresh and touch base on combustion analysis, okay, and draft testing. Where the proper spot is to take the draft. And I'm going to put a link in the video here, okay? So this was calibrated outside the fresh air. You do not start this in the basement. Make sure the water's out of here in your little collector and in the back here. This is the Testo 300. So we're gonna turn this on. Now this boiler was modified 2 years by me. 2 years ago, I modified this because it was taking too much air in the draft box and lowering the oxygen and raising CO. There was actually a problem here before I even got to this 2 years ago. But for the time being, we're gonna test this now. This is a damper, gas barometric damper. You're allowed to modify these if anybody's worrying about it. So we test the combustion on the damper below this. Below the dilution air. Okay, what this does is controls the draft and combustion air. You're not supposed to put this in unless you're certified to modify this. Okay, so you can see I got my yellow tag here, modification. So we're going to test this below the dilution air. Okay, now I don't want to get my fingers in the way. I want to straighten this side. I don't typically use a cell phone. I forgot my GoPro this morning because of certain things. All right. Okay, you can raise the thermostat, please. So this gets inserted halfway and pulled out. I didn't put this boiler in. This was in. Raise it up. Here we have ignition. Now, you do not wait to allow the boiler to heat up. Okay. You have the probe in on startup when you do this. You do not wait to heat this up. And you can see this went up to 419 and dropping down. You can see that this is slightly working. So what that's doing is it's forcing the air to go from the bottom instead of all in this draft box. Now, so we got about 11.8 oxygen. Parts per million are dropping. This is a Dunkirk, actually. Lennox Carrier Dunkirk. Now, so for about the first 5 minutes is what you want to do. Now this oxygen isn't bad due to the fact that the T-stack is pretty good. It's not under fire. That's increasing. So originally this boiler, if I recall right, I did make a video of it, but I got messed up or accidentally deleted. I couldn't remember 2 years ago in 23. When I came to put a new thermocouple, I believe, and clean this, it went up to like close to 3,000 parts per million, which is very dangerous and out of specs for startup. So you can see how that's working. That's controlling the draft, and this is controlling the combustion air to force the air to go from the bottom, which is stabilizing this to about 4 parts per million. Another thing that I've been seeing, the person that's doing the video, they're using a Testo 320. Some people use other brands. These have to get sent back to Testo to get calibrated. The sensors, oxygen and CO sensors, they last a long time in this. I believe this year they're going to change the CO sensor in an oxygen because it's over 3 years. From 2021, they calibrate this for me. So if you're not getting these calibrated by the factory, you can't calibrate this. And something happens in a court of law, I'm not an attorney, you'd have a difficult problem. Because when this gets calibrated by the factory, you have a certificate. And this has a software, it's updated. So as you can see, we're running about 2 ppm carbon monoxide. This boiler is fine-tuned. I tuned this 2 years ago. It was a very dangerous boiler. Now what happened here was a previous guy, they had some wires that melted, it carboned up, they had to clean this. They didn't know what was going on. And the T-stack is good. You can see the oxygen is 12.1. You can't always get them perfect. I'm not going to increase the gas because the temperature is very good. So I'm letting this sag a little bit. So we'll try it like that. So you can see we're burning 2 parts per million. If this thing would spill, which it ain't, nobody would die. Nobody would get injured, you know. So a lot of these things that you're hearing on the news, there's simple things that now I'm below that dilution there up here, but sometimes you have to hold them down a little bit. I didn't want to make a hole through the electronic damper. So this is legal to do. So this is how you do a combustion test with a damper. Okay, or you could take it actually down here, drill a hole, but I prefer to do it up here because you're far away from inside there of the, you'd have to drill a hole up in here and get in, up into the cast iron section to get the flue gas, but this is good. So it's between 12 to 1 ppm. All right. So what we're gonna do is I'm gonna pull this out and take the reading down. I'm gonna screw this one out. As you can see, so we're gonna reinsert this down right about on an angle, okay, below further. This will start to re-register. We're actually 1 ppm. I was a little bit higher, but I have this, as you can see, pointed down on an angle. Be careful not to touch the we'll see how the temperature goes. We may have to give it a slight gas adjustment. I don't know. It's been a while. Now gas purveyors, they can change. I've seen it happen. You may be more gas one year and none the next year. It's how they're providing the. I put that back in to see what it would do. Now, if the hole's too big, you get air in there, we'll get an inaccurate reading. So this is going back to the way it was. As you can see, the T-stack is going back to 399, so we're good. It's not underfired. 575 is maximum. So if you're between 320 to 575, 320 is low. This is a first floor unit. So for these numbers here of the T-stack temperature compared to the auction, it's not underfired. There's not a lot of auctions because we're forcing the air to go from the bottom, and due to the conditions of this room here, you know, it's a closed room. But anyway, we're gonna save this. Now, what I'm gonna do is I'm gonna show you where you take the draft. So this goes from flue gas to draft. Now, this will calibrate. You start it and it'll say 0 required. This is the Testo 300. This is a very good instrument. Okay, so one of the discrepancies, and it'll tell you zeroing is finished, is some knucklehead is trying to tell an experienced certified combustion analysis, CO safety technician, I'm a registered plumber in Pittsburgh, boilers are under plumbers, not HVAC. So this boiler is a pressure vessel. You can heat domestic water. We have jurisdiction on it. It's in our code. So this, you do not read a draft reading from the right. And I called Testo to confirm this. And you can too. So how you take your draft reading, you start from the left, minus 0.0. This first 0 is your draft reading, okay? This first 0 after the decimal is your draft. If you don't believe me, call Testo. So this would be minus 0.0. There's no draft here. This is outside in the room, okay? And as you can see, we're negative. This basement is negative. It's not positive. Now over here, it's positive. So what I'm gonna do for the purpose of here is I'm gonna close this door to see if we're still positive. If you're too positive, it's no good neither. So you can actually use that instrument analyzer to determine if your basement is positive or negative. The basement has to be positive. You see here? So I close the door. It's negative, positive, negative. There's a fluctuation. Now, we're gonna reinsert this in here, okay? Now, that is not the draft reading, okay? These first two numbers are not draft reading. So this, we're gonna point down in because so we got a minus 0.03 draft rating. Those first two numbers are not a draft rating. So this, I pointed it up, okay? So that's where your draft rating are taken from. If you put this analyzer in a flue, we're gonna do that one because that has a draft hood. If you put this in and you're only getting two numbers from the right end, that is not your draft. This is your draft. Minus 0.03. That's the draft. Now when you take this out, I took it out, there's no draft. So those two numbers would not be a draft. I have this out of the border, okay? So it's your minus 0.0, and then after that, okay? That's what that is. And that's how you conduct a draft test with a barometric damper. You can see I put it back in. So this should be negative, but it is negative. Minus 0.03. That's your draft reading there. And your T-stack. Any of these numbers over from the right end, the first two are not a draft. All right, so we're gonna adjourn this. But for the purposes of the damper, you don't do a draft on it. I mean, you can use it to set it. I have no washer on here. We don't need it. Some you do. Now, I can't quite remember. I had a hole up there. So what we're gonna do is we're gonna take a quick draft on that flue pipe just to see how it is going up the chimney. So, even though we have the damper, okay, so we have that in there. Let's see what we got. So on the chimney part, we got a high draft. You can see it's minus 0.462. So when you conduct a draft, you do not use the first two numbers from the right end. Okay? Preferably use an air meter. I have the Dwyer. So I'm pointing this down and went back. It's between 4 and 3. This is on the dilution air side of the damper. That's the velocity going up the chimney. It's a high draft. So that's what that is, okay? And that's probably what caused the sealing off of the flue gas. Alrighty? Now, that's how you conduct a combustion analysis in draft reading of a boiler with a barometric damper. Was the draft hood, the test gets done above, not below the draft hood or above the draft or in the draft box. It's in a link that I have. I'm certified, I know what I'm talking about. To measure the draft, you put it above the draft box, draft hood, excuse me. And likewise, if this was open, the draft would be taken up here where the dilution air gets in to make the velocity of the draft going up the chimney. Not down here. Now, when this is sealed off, you would take the draft below this damper to adjust the damper because we're sealing this draft box off and forcing the air to go from the bottom. This damper controls combustion air and draft. So the draft would be below. And the same with the power burners, what the hell they call those? Oil and gas power burner. The draft gets taken below. Not on atmospheric boilers, okay? So combustion analysis here, draft above this draft hood or this draft box above for the draft, unless it's sealed off. There's no question if or and how you were taught. Look it up. Look at the link. This is a proper method. It's written in the instruction in the link that I have. Plus, when you go to an NCI to get certified, you'll learn it. And that's all I have for this video. I'm not trying to defame nobody. I didn't mention no names, but whoever you're watching for the combustion test and draft test, they're teaching you wrong. It is not the way you do a draft test on an atmospheric boiler. So I'm going to repeat it for the last time. This is where the combustion test is done, okay? Then your draft gets taken up here within 18 inches of this, where the dilution air gets in, is sucked in. That's the draft. So we'd measure that up on the flute pipe, okay? So until the next adventure, this is Vince Marino Plumbing LLC in Pittsburgh. I hope you got educated. I'm not trying to show off or teach anybody. This gets me traffic to my business and website. If you're in Pittsburgh, you have any boilers, steam boilers, hot water boilers, give me a call. And as you can see here, this is a potable water expansion tank. I'm not going to do a video on this. I got enough to do here. And I just wanted to touch base on the boiler itself. And you can also see another mistake. They used the potable water regulator for this boiler. I mentioned it to the owner already. So until the next boiler adventure, this is Vince Marino Plumbing LLC in Pittsburgh. You got any problems? Give me a call. VinceMarinoPlumbingLLC.com. I'm a certified combustion analyst, CO safety. You got any carbon monoxide issues? You were told that your boiler or furnace has to be replaced, or if you got a cracked heat exchanger, you want an expert opinion, give me a call. Until the next adventure, arrivederci.